creating our review video for section 12.1. That's chapter 12, section 1. And our learning target for today is to count outcomes by using a tree diagram or the fundamental counting principle. So let's define our series of terms for probability here. The first one is outcome. Well, one possible result of a probability event, for example, 4 is an outcome when a number cube is rolled. So if I roll a die and it's got 1, 2, 3, 4, 5, or 6 on it, one of the possible outcomes is to roll a 4. An event is that outcome when it's been completed, and we know that it actually came up a 4 or it came up a 6. Sample space is a set of all possible outcomes of a probability in an experiment. And the last term on this slide, a tree diagram is a diagram used to show the total number of possible outcomes in a probability experiment. Two more terms for us. Probability is the chance that some event will happen. It is the ratio of the number of ways a certain event can occur to the number of possible outcomes. So how many outcomes that are what we are measuring to the total possible outcomes. And random. Outcomes occur random even if each outcome is equally likely to occur. So here's the first problem. We're asked to flea market. A vendor sells new and used books for adults and teens. And today she has fantasy novels and poetry to choose from. So it says draw a tree diagram to determine the number of categories. So I'm going to start. You could either have new books or you could have used books. Then after that, you could have adult or teen. And after adult, you could either have a novel or you could have poetry. So after a teen, you could have a novel or poetry. And if you bought used, of course, you could have adult or teen. And if you bought an adult used book, you could also get a novel or poetry. And a used teen book, you could get a novel or poetry. So that's the factor tree or the probability tree. And you can see here that I could have a new book for adults. That would be a novel. Or I could get a new book for adults that's about poetry. So new for adults about poetry. I could also have a new book that's for teens, and it's a novel. New book for teens, that's a novel. And a new book for teens, that's poetry. That would be this branch of the tree. I could also have used books that are adults and novels. So used book for adults, that's a novel. Used book for teens, that's a novel. Used book for adults, that's about poetry. And a used book for teens about poetry. So there are 1, 2, 3, 4, 5, 6, 7, 8 different possible outcomes of this scenario. Please look at this. There's two, just a reminder here, there's 2 choices to make here. There's 2 choices to make here. And 2 choices between the novels and the poetry. So it's 2 choices, 2 choices, and 2 choices. All right, a store has outfits on sale. You can either choose striped or solid. So we have striped or solid. All right. Then you can also choose a green, pink, or orange. So you could choose here green, pink, or orange. And then you could either choose long sleeve shirts or short sleeve shirts. So here would be with the green, I could go long sleeve or short sleeve. With the pink, I could go long sleeve or short sleeve. And with the orange, I could go long sleeve or short sleeve. All right, with solid, I could make the same kind of choices. I would have a green one, pink ones, or orange ones. With green, I could either have long sleeve or short sleeve. With pink, long sleeve or short sleeve. And with orange, long sleeve or short sleeve. So the possible outcomes are striped, striped, striped with green, and long sleeve. I could have striped with green and short sleeve. I could have stripes with pinks and long sleeves. I could have stripes with pinks and short sleeves. I could have stripes with orange and long sleeves, or I could have stripes with orange and short sleeves. Solid, I could have solid with green and long sleeves, or solids with green and short sleeves, solids with pinks and long sleeves, solids, pinks and long, solids, pinks and short, solids, orange and long sleeve, solids, orange and short sleeves. I think if I counted those as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And this time I want to look at the choices we had. We had 2 choices on the first one, we had 3 choices on the second one, and we had 2 choices on the third one. So 2 choices, 3 choices, and 2 choices. 12 different combinations. Key concept, fundamental counting principle, it says an event M has M possible outcomes, and event N is the N possible outcomes. The event followed by event N has an M and N. So what that means is, since I had 2 choices, we'll go back to the one about books. If I had 2 choices, used or new, I'd have 2 choices. Then from that, I could choose adult or teen. I'd have 2 choices, and followed by novel or poetry. So it'd be 2 times 2 times 2, or 8 different possible outcomes, 8 different possible outcomes. If we went back to the one before, which was about the shirts, we could have striped or solid. So we had 2 shirts. We had 3 different colors. And then we had 2 different lengths of sleeves. So we had 2 times 3 times 2. 2 times 3 is 6, times 2 would be 12. So it does check out for the previous 2 problems. Let's look at another example. Restaurant manager assigns different codes to all tables in a restaurant to make it easier for the waitstaff to identify them. Each code consists of a vowel, A, E, I, O, or U. So that's 1, 2, 3, 4, 5. 5 different choices there, followed by 2 digits from 0 through 9. So the next thing would be 0 through 9. There's 10 different things to choose from there. And the second set of digits, there's 10 different things to choose from there. So 5 times 10 is 50, times 10 would be 500. There's 500 different possible codes that could be used to identify the tables. A middle school assigns each student a code to use for scheduling. Each code consists of a letter followed by 2 digits from 0 through 9. So it would be a letter, say the letter L, times 9, our letter, then the next entry would be 9, for example, and 2 for the last one, so it'd be L92. Letters to choose from, there's 26 different letters. For the first digit here, there's 10 different digits to put there. And for the second one, there's 10 to put there. So 26 times 10 is 260, times 10 is 2,600 different codes that could be for identifying middle school students in that school. What is the probability that Lena will guess her friend's computer password on the first try? All she knows is that it consists of 3 letters. Well, if it consists of 3 letters, that would be, that would be 26 for the first letter, times 26 for the second letter, times 26 for the next one. Her probability of getting it correct would be that she chooses the right one. There's only one combination that works, and so that would be 1 out of, and if I multiply 26 times 26 times 26, I get 17,576. So she has a 1 in 17,576 chance of getting the combination on the first try. What is the probability that Shauna will guess her friend's locker combination on the first try? All she knows it consists of 3 digits, 0 through 9. So there are 10 numbers to choose from on the first combination, the first digit of the combination. There are 10 to choose from on the second, and 10 to choose from on the third. So 10 times 10 times 10 is 1,000, and she has a 1 in 1,000 chance of getting it right on the very first pick. Thank you.